Today, we're diving into one of the most clever tricks in modern AI. We're going to talk about how to take these massive, powerful models and shrink them down so they can run on the very device you might be watching this on right now.
So here's the big question, right? How do we take these giant, brainy AI models and actually fit them onto our everyday devices? I mean, state-of-the-art AI is incredible, but it's usually way too big and power-hungry for our phones or laptops. Figuring this out is really the key to unlocking its full potential in our day-to-day lives.
You see, the incredible power of modern AI? Well, it comes at a cost. And that cost is size. These models are often massive, and they need a huge amount of memory and computer power to run, which just makes them totally impractical for most of the hardware we all use.
And the reason they're so huge comes down to something called parameters. You can think of these as all the little knobs and dials that hold the model's knowledge. The thing is, there can be billions of them, and by default, each one is stored as a really high-precision number, a 32-bit floating point number to be exact. All that detail adds up fast.
So how do we solve this size problem? Well, it turns out there's a brilliantly effective technique called quantization. It's one of the most important ways we optimize these models to make them way more efficient and accessible for everyone.
So what is quantization really? Simply put, it's the process of reducing the precision of the numbers inside the model. We're basically making the model's internal language a lot simpler and less detailed. And when you do that, the model's overall size shrinks, like a lot. It's a really powerful form of intelligent compression.
Okay, theory is great, but let's look at a real-world example. We're going to see exactly what happens when we apply this technique to Meta's Llama 3.2 model. And, the results are pretty staggering.
Now just look at the visual here. It tells the whole story. On the left, you've got the original 32-bit model, clocking in at 4.6 gigabytes. Just by cutting the precision in half to 16-bit, we literally chop the size in half. But then, when we push it all the way down to 4-bit, the model is less than a gigabyte. It's an incredible demonstration of just how powerful this is. And here are the precise numbers to back that up. The 32-bit model starts at over 4,700 megabytes. By the time we get to 8-bit, it's already down to about 1,400. And at 4-bit, we're looking at just 965 megabytes. The savings at every step are just huge and consistent.
So let that sink in for a second. We've taken a 4.6 gigabyte model and we've shrunk it to under 1 gigabyte. That's more than a 4 times reduction in size, just by changing how we store its internal numbers. Okay, so we've seen what quantization does to a model's size. Now let's peek under the hood and look at how it works. What's actually changing inside the model's data, inside its weights. This here is the perfect before and after shot. On the left, you see the original 32-bit weights. See how they're these complex floating point numbers with lots of decimal places? Now look to the right. After we quantize it to 8-bit, those same weights are converted into simple, whole numbers, integers. This is the core transformation right here.
So how does that even work? Well, the logic behind it is basically a remapping of the value range. The original 32-bit weights in this example, they went from about negative 0.67 to positive 0.58. The quantization process takes that entire range and maps it onto the much simpler integer range of negative 127 to positive 127. It's just a super clever way to keep the essential information, but in a much, much smaller package.
Okay, this all sounds pretty amazing, right? But it does bring us to a really important point, the trade-offs. Like with any kind of optimization, quantization is all about making a strategic choice between pure efficiency and absolute top-tier performance.
So the trade-off here is pretty clear. On the pro side, the benefits are just immense. You get a massive drop in model size and memory usage, which means you can run these amazing models on smaller devices, and they run faster. The con is that by reducing that precision, you can get a slight drop in the model's performance or accuracy. But here's the key. For most real-world uses, that tiny dip in accuracy is a price well worth paying for the huge, huge gains in efficiency and accessibility.
At the end of the day, quantization is so much more than just a compression trick. It's really a critical enabler. It's the technology that closes that gap between a massive AI stuck in a data center and the devices we use every single day. It is, pretty much, what makes powerful artificial intelligence accessible to all of us.